Algebras. Welcome to your Chapter 10 exam review. As the usual goes, these are the outline of the questions that I will ask you on the test. And so I have 5 multiple choices that I'm going to ask you, and then exact repeats with just different numbers on the next page. So I will do the first 5, you will do the next 5, then I'll do one, then you'll do one, and so on until we get to the end. Okay? Okay. Let's start with number 1. The solutions to the equation x plus 3 in parentheses squared equals 7 are, or is, because it should be are, there's more than one. Oh, let's see. Well, this is like completing the square has happened already, and we factored it into the binomial squared. That is the whole point of completing the square, is to create that binomial squared. So now all we have to do is the opposite of squaring something is take the square root. So take the square root of both sides. Get x plus 3 equals plus and minus radical 7. And yeah, that's radical 7 because 7 is not a perfect square and not evenly divisible by a perfect square. Last thing we do is subtract that 3 over to the other side. It always goes in front of the plus or minus. So we get negative 3 plus or minus radical 7. So let's get that answer correct right here. And of course, it does say in the directions to put the choice on the line provided. So even though this itself isn't the exam, were it the exam, you would get this wrong if you didn't use the blank. That's why it's there. The zeros of the function are, okay, that just means replace f of x with 0. And now we've got 0 equals x squared minus 4x minus 12. Now, in this chapter, we now have 3 methods to solve quadratic equations at our disposal. We can solve by factoring, we can solve by completing the square, we can solve by quadratic formula. You're welcome to pick whichever you want as long as the answers are factorable, right? So you can pick any of those to solve this if your answers are factorable. This is factorable, and right now, I can tell that because my only options of answers are integers. There's nothing with a radical present, which tells me that factoring is an option here. So the factors of 12 that we'll subtract to give me negative 4 are 6 and 2. 6 is the bigger of the 2 factors, matches the same sign as the middle. Since the n number is negative, this has to have the opposite sign, which means over here I get x equals 6, and over here I get x equals negative 2. And that means that 6 and negative 2 are both answers for the zeros of this function. Now, if my options had a radical in them, the only things I could do would be complete the square and quadratic formula. That particular trinomial would not have been factorable. All right, an equivalency one. We had a whole lesson on this. Lesson 2 was all about this equivalency thing. So what I'm going to do right here is I'm actually going to complete the square. So I'm just going to start things off instead of solve the whole thing by completing the square, right? I'm really just going to solve things. So I start by adding that 13 over. I get x squared minus 6x plus blank equals 13 plus blank. Because whatever I do to one side of the equal sign, I have to do to the other. Remember that this is always plus blank, because even if I end up with a negative number when I square it, it's positive, right? Which is going to happen here. I take the middle number divided by 2 and square it. Negative 6 divided by 2 is negative 3. Negative 3 times negative 3 is positive 9. So no matter what, this thing that I'm doing to both sides is adding that number to both sides. Now I take this and I factor it to be one binomial squared. And the way I do that is to just take the middle value and divide by 2. So negative 6 divided by 2 is negative 3, which means the binomial squared is x minus 3. On the other side, these are both numbers. 13 plus 9 is 22. And it's looking for an equivalency, so that's where I'm going to stop and then analyze my multiple choices, and look at that. X minus 3 squared equals 22. There you go. How many real solutions exist for g squared plus 2g minus 6 equals 0. Lesson 5 was all about how to determine the number of real solutions you have to a quadratic equation. And in this case, we already know that since the highest exponent present is a 2, there will not be 3 solutions here. So 0, 1, or 2 are my only options, and that depends on the value of the discriminant. Now, the discriminant, remember, is the b squared minus 4ac part of the quadratic formula. This is the stuff that's under the radical in the quadratic formula. That means if the value of this is positive, then you're going to have 2 real answers. If the value of this is 0, you have 1 real answer. And if the value of this is any negative number, you will have 0 real solutions, because you can't have a negative number under the radical and still be considered a real number. Okay, so since this is in standard form, the b is 2 in parentheses squared minus 4 times 1 is the number in front of the g squared, that's a 1. And then the number by itself at the end is the c with its sign. So I could plug this straight into my graphing calculator, or 2 squared is 4. Negative 4 times 1 is negative 4. Negative 4 times negative 6 is a positive 24. And then 4 plus 24 is 28. Positive number, 2 solutions. And then what is the value of c that would make the polynomial a perfect square? Take the middle term, divide it by 2, and square it. 16 divided by 2 is 8. 8 squared is 64. That is the c term. Okay, zoom out real quick so you can see all my answers again. Notice I don't just get the answer without a little bit of work maybe to get me there. So you want to make sure you're doing that when I leave you to do 6 through 10. Okay, so we're about to pause it. Hold on, just got to find my pause. We're about to pause it so that you can try 6 through 10. Okay, same types of questions, right down the line in order. I'm just going to throw out a fair warning to you. Let's see, where did I want to do that fair warning? No, you know what? I actually think you can handle it, because yes, that's a negative, but use that discriminant and remember what that a term is. Okay? All right, guys, I'll be right back with answers. Try these. I'll see you in a sec. Okay, let's check our answers here. Give a sec. Check everything. Make sure you got the right stuff. Let me know if you have questions, and I will move on to the next part of the test. So the next thing we have to do is to solve quadratic equations by completing the square. So the whole shebang comes together, not just pieces of it like we looked at here. I'm going to do number 13 and number 15, and I will leave you to do 12 and 14. And do note that there are different directions there. So both directions we're solving for x by completing the square. But the 12 and 13, leave your answer in simplest radical form, and 14 and 15, we round our answer to the nearest tenth. Okay, so let's begin with number 13. Actually, this kind of starts nice because I want to just add a plus blank to both sides, right? So x squared plus 2x plus blank equals 3 plus blank. And again, that blank will always be positive, because even if you have a negative in the middle, when you square it, it's a positive thing that you're adding to both sides. 2 divided by 2 is 1. 1 squared is 1. 1 goes on the blanks. Now, this becomes a binomial squared, so that I can take the square root of it. Well, here, these numbers add up. So right there, let's see, to figure out the value in the binomial squared, well, we know there's an x in the front. 2 divided by 2 is 1, so this is a positive 1. There it is. Now, because you've got x plus 1 in the parentheses squared, the opposite of squaring something is to take the square root. So I take the square root of both sides. This x plus 1 comes out because the square and the square root cancel each other out. Meanwhile, on the other side of the equal sign, I've got something under the radical, and I've got to deal with it. So let's see, is 4 a perfect square? Oh, yeah. So what comes out of that radical is actually plus and minus 2, because I can take the square root of 4. 4 is a perfect square. So now to finish up, I subtract this 1 from both sides of the equal sign. It always goes in front of the plus and minus. And now I combine those terms because they're both rational. And I've got two options here. Negative 1 plus 2 is positive 1, and negative 1 minus 2 is negative 3. And that is my answer for x. And I didn't have to worry about simplifying a radical because this was a perfect square. So simplifying the radical meant taking its square root. Now let's do number 15 together. In this one, I will show you simplifying the radical before I plug it into my graphing calculator just to get you on both ends of this, right? So number 15, this time we're given standard form to start. So the very first thing we need to do is actually to add 6 to both sides of the equal sign and leave a plus blank here and then have a plus blank added over here. So now we already know what goes in the blank here because it's the same as the one before. But let me again remind you how I get it. B term divided by 2 and squared. So 2 divided by 2 is 1. 1 squared is 1. So now this is a perfect square trinomial. So it factors to become 1 binomial squared. And this over here are two numbers that add up to 7. So now to get what goes inside the binomial, I take the middle term and just divide it by 2. So 2 divided by 2 is 1. So g plus 1 is in the parentheses squared. Now, to free g so that I can get it alone, the opposite of squaring something is taking the square root. So I take the square root of both sides so that these cancel and leave me with g plus 1 equals plus and minus. Okay, let's see, wait. 7 is not a perfect square, and 7 is not evenly divisible by a perfect square. So guess what? It's just plus and minus radical 7 that comes down to this line. Still irrational. Two irrational answers are going to come out of this. Now I subtract 1 from both sides of the equal sign to get g fully alone. So negative 1 plus and minus radical 7 are my two answers. That's negative 1 plus radical 7 and negative 1 minus radical 7. And to find the decimal equivalence, I just plug that into my graphing calculator. So I'm going to have two answers for g rounded to the nearest tenth. So let me grab my graphing calculator and make it just a little bit bigger so you can see my screen. Okay, so I'll start with negative 1 plus radical 7, so second, and the square and the x squared button gives you the square root. Put 7 under that guy and press enter. So 1.6 is my first answer for g. Second answer for g, I'm going to have the same thing, but I'm going to put a minus sign between. So I can press second and enter to go back to the entry that I just put last. And I just have to arrow to the right to change this plus sign to a minus sign. So negative 1 minus radical 7 is negative 3.6. So my two answers for g here are negative 3.6 and 1.6. Oh, sorry. My graphing calculator is still kind of big for you to see those. There you go. Okay. All right, I'm going to pause it here. Have you try 12 and 14 right now and check your answers for those before we move on to solving quadratic equations using the quadratic formula. All right. Pause it right here. Take a beat. Try 12 and 14 on your own. Remember on number 14, divide everything by 2 before you do anything else. Okay, good luck. And how did we do? 22 is not a perfect square, and it is not evenly divisible by a perfect square. So when I encounter radical 22, it will not simplify any further. So So I just subtract that 3 over and put it in front of the plus and minus. Remember that this is two irrational answers. It's 3 plus radical 22 and 3 minus radical 22. Down here, I reminded you, you have to divide everything by 2 to start. Then you can add your constant to both sides that makes this side a perfect square trinomial. And it's 25, of course. Negative 10 divided by 2 is negative 5, and negative 5 squared is positive 25. So that's what I add to both sides. Again, 33 under the radical, not a perfect square, not evenly divisible by any perfect squares. So it's stuck there. We just add that 5 over. This time, the answer needed to be to the nearest 10th. So 5 plus radical 33, 10.7. 5 minus radical 33, negative 0.7. There's my two answers. Okay, moving on. About to solve quadratic equations using the quadratic formula, greatest formula ever. It looks like, since I'm asking it here, I'll probably be asking it on your exam, but it'll be a cinch for you. Since it's a cinch for my toddler, I'm sure you can memorize it as well. X equals x equals negative b plus and minus the square root of b squared minus 4ac, all divided by 2a. Write it out. Remember, everything is divided by 2a. Remember, all the stuff under the radical hat is b squared minus 4ac. This piece is called the discriminant because its value determines what type of roots I get. Okay, this negative b over 2a will actually mean something in chapter 11 as well. So it's kind of neat how this quadratic formula really helps us out in a lot of ways. Okay, so make sure you have that memorized. Get that song stuck in your head before you go and take the test, right? And now let's solve our quadratic equation using the quadratic formula. I am going to do number 18. I'm going to leave you number 17. So let's get standard form. Subtract that 10 over to be with the 3x squared. It actually didn't matter which direction I went here, but I need to have ax squared plus bx plus c equals 0 form. My a is 3, b is negative 10, and c is 0 because there's not a constant term at the end of that binomial. There's no trinomial this time. C is allowed to be 0, B is allowed to be 0, A is not allowed to be 0 because then you wouldn't have an x squared and it wouldn't be a quadratic and we wouldn't be solving it this way. Write out your quadratic formula when using it and then show the plug-ins that you're doing to the formula so you make sure you get it right. So negative of negative 10 plus and minus the square root of negative 10 squared minus 4 times 3 times 0, all divided by 2 times 3. So I wrote a little big there. I'll do the simplifying right here on my graphing calculator for you. So I'm going to simplify the discriminant right here. Let's see, in parentheses, negative 10 squared. So I'm putting that in parentheses to make sure I do it right. Minus 4 times 3 times 0. Well, wait a minute. Anything times 0 is 0, right? So the back end is 0. And negative 10 times negative 10 is 100. This is a perfect square under the radical. So I get a positive 10 plus and minus the square root of 100 divided by 6. So actually, this means this was a factorable polynomial. Okay? 10 plus and minus 10 divided by 6. So there's two things that I'm going to get here. Make my graphing calculator smaller again. 10 plus 10 is 20 over 6, and 10 minus 10 is 0 over 6. So my two answers are both divisible by 2, 10 over 3. My two answers are 0 and 10/3. There we go. Easier to represent as 10/3 because otherwise that's a repeating decimal. Cool. You'll try number 17. Before I have you pause and try 17, I am also going to show you how to find out how many real solutions a quadratic has. And I'm going to remind you, since this is a multiple choice, you're just using the same exact method here, where you use b squared minus 4ac, just the stuff that would be under the radical in the quadratic formula to determine the value. All right, so let's do number 21. B is 4, so 4 squared, minus 4 times negative 2 is A, times negative 14 is C. And let's see what we get. And I can use my graphing calculator to do the calculation part. So 4 in parentheses squared minus 4 times negative 2, the signs are important, times negative 14 gives me a negative number. If your discriminant is negative, there are 0 real solutions. I don't want to solve for x, just so you know. State the number of real solutions. That's what I'm going to ask on your test. Just the number of real solutions. 0 real solutions. Anytime you get a negative number on the discriminant, you have 0 real solutions. If you get a 0 out of the discriminant, you have 1 real solution. If you get any positive value out of the discriminant, you have 2 real solutions. Make sure your quadratic is in standard form when you go to do 19 and 20 right now. So you're going to do 17, solve using the quadratic formula, and then 19 and 20, just state the number of real solutions, get standard form, use the discriminant to do so. We'll come right back and close up, pause it here, give those a try. Okay, let's check our answers for 17, 19, and 20. Notice on number 17, the number I get, the discriminant, the thing under the radical, is a non-perfect square that is evenly divided by a perfect square. So I do have to simplify that radical. Number 19, the discriminant comes out to be a perfect square. So actually this trinomial was factorable. And then on number 20, the discriminant comes out to be a positive number. And again, we know any positive number as the discriminant means 2 real solutions. So both of these are 2 real solutions. I'm just pointing out that this was actually 2 rational solutions. This is 2 irrational solutions because this is not a perfect square. It's a positive number, but it's not a perfect square as the discriminant. Okay? So make sure you know how to do all of these questions because these are the questions I am going to be asking you on your Chapter 10 exam. If there is a question you don't know how to do, please contact me before you take your Chapter 10 exam so we can go over how to do this. All right, guys. This has been your Chapter 10 exam review video. I think you're ready, but if you don't feel you're ready, contact me before taking the test. I will see you very soon. Have fun. Get that quadratic formula song stuck in your head. Write it down correctly. Bye, guys.